Hello everyone, this is Lokesh. I am here telling a brief introduction of the processors, the architecture of the processor. Here we have the two different types of different architectures. One is Cisc, another one is a RISC. You know that why we use the processors? To execute the programs and to execute the instructions. Here is an architecture to execute the instructions. The set of instructions is set of a program, right? So there are many processors. We know that there are Exynos, Apple Bionic chip, Snapdragon, and many other. And different processors use a different architectures based on their purpose. And by those purposes, we have two types of architectures. One is the Cisc, another one is the RISC. Let me say in brief manner, differentiating these architectures. C defines computer having set of instructions or complex. The set of instructions in this computer are complex. They are like memory, register to memory, and very complex instructions like indirect, direct. Like we have the many addressing modes, and those addressing modes are very used to how the processor goes very fast. If the addressing mode looks very simple, the processing goes very fast. Here, the addressing mode which it represents register to memory, direct, indirect, and register to register. Register to register is very fast addressing mode, but register to memory and some implied, those all are very compared to slow rather than the register to register. And when it comes to the RISC processor, the computer having set of instructions or in a reduced manner, not eliminated. We are not eliminating the instructions. If we eliminate the instructions, the output was definitely wrong. There is no other thing. So we are reducing the set of instructions. Okay. How we reduce? By using the register to register addressing mode. We use only the register to register addressing mode. Do you think we will use the immediate addressing mode? Yes, definitely. We will use the immediate addressing mode. The main theme of the RISC is process the instruction fastly. Immediate addressing mode is a small, takes less time rather than the register to register addressing mode, so that immediate is also used. Here in the complex Cisc processor, we also use the register to register addressing mode and also immediate addressing mode, but it is very flexible using of the addressing modes. You can use any addressing mode. So when you use the register to memory, getting data from the memory to the register, it takes lots of time because let's think an example. This is in a classroom. Here you want to ask a pen or pencil something from your friend, and you just ask him. And if you want to ask the pen or pencil from the other class, you need to take permission and get out and get into the other class with the permission and take it and again get out and again get into your classroom. It takes lots of time. As it is. Compare this example with the registers and the memory address line. Register to register is just like asking a pen in your classroom, in the classroom, and asking a pen where he is in the next classroom is just like register to memory as it is. And register, it is memory based processor. As just we had a discussion that memory takes a lot of time. So all the addressing modes probably more in using memory only, and this is a register page. It only uses the registers, less registers in the Cisc, because here we don't have the work with the only the registers. We can use the another addressing modes like using the memory, right? So we use a very little registers like 8085, we use the 7 registers. 8086, we use the 8 registers. Okay, and more registers in the RISC. We are doing all operations or all the fetching or execution with the registers. So we need lots of registers. For example, the PIC uses 4000 registers in it. Okay, 4000 registers. You may think about it, how big the process. And the poor pipelining, really the pipelining is very important while executing, fetching and those stages. The pipelining plays a very key role, big key role. Let's give an example why this having the poor pipelining and excellent pipelining in the RISC. Okay, here I took example of getting the data from register to adding 2 registers. We know that there will be a sum between the R0 and R1, and that sum is again stored into the R0, right? This is the basic assembly line. And adding R0 and in the memory location 3000 hexadecimal. Okay, that means first it have to read in the memory location and then from the R0 and should be added. This takes really lots of time. Wait, I have an example for that how it takes more time. Here, getting data from the register takes 3 nanoseconds and getting data from the memory takes 6 nanoseconds. These are not the exact values, but we can hypothetically take these as an example. Okay, this is a pipelining structure, and we know that what is the pipelining. The pipelining main theme is execute an instruction and also fetch the new instruction. While fetching the new instruction, you can also execute the previous instruction within a cycle. This is really very fast performance. Non-pipelining don't allows this. You have to complete fully the fetching and execution of a single instruction. After that, we have to fetch or execute or any stages of the pipelining after the first instruction. Okay, here you can see that the execution and the fetching are taken in the one cycle only. Here, let's see for the fetching from the register it's 3 nanoseconds, and here the 3 nanoseconds, and here the 3 nanoseconds. It takes only the 9 nanoseconds. Remember, this is taking only 9 nanoseconds. This is RISC. Why it is RISC? Because all the registers, we don't have any memory, we have only the registers, so that everything is taking 3 nanoseconds of one cycle. Getting? When it comes to the Cisc, you may observe that it taking the 3 nanoseconds, it taking 3 nanoseconds, and 3 nanoseconds. Why here 3 nanoseconds? Because we are using an memory addressing mode, register memory addressing mode, so that taking 6 nanoseconds. It takes first 3 nanoseconds will complete in one cycle, another 3 nanoseconds will complete in another cycle. Getting? So how much time it takes? It took 12 nanoseconds. As we compare, this is taking the 9 nanoseconds, this is taking the 12 nanoseconds. Getting the difference, this is 3 nanoseconds. You may think, oh, it's just 3 nanoseconds, it's a very small, it's just a blink of eye. For the computer, it can do many things in in the difference of 3 nanoseconds. So here we can define that the pipelining of Cisc processor is some poor and the pipelining of the RISC is excellent, far excellent, extremely excellent. And you may guess, we found a stall. Having a stall makes the less utilization of the CPU. If you have the stall, the utilization of the CPU is somewhat decreased rather compared to again. And also sometimes the Cisc processor acts as a non-pipelining execution, fetching or execution. It's just like as a non-pipelining. Having we introduce the pipelining to completely process fastly, and if it is gets like a non-pipelining, what's the use, right? So it's called very poor pipelining. Variable execution, fixed execution time. Just we see here. Maybe let's take another instruction. Here we have the F3 and E3. Here we are using the register. Here we use the memory. The execution time is varied. Different execution times it taking, right? So the execution time is varied from one instruction to another instruction. Microcontrol unit, hardware control unit, microprogrammed control unit. You may know about it. Here one thing should be said: hardwired, not hardware. There is a difference between hardwired, hardware. If we have the hardwired, the execution or fetching or processing, it takes very fast because the set of instructions are already was loaded in it, already known by the control unit, and in the microprogram we have to write it because sometimes we have to update the microprogram, and also here control unit. I think you know the control unit very well. That the control unit, what it gives the triggers to what? Registers. For example, implementing the program counter, getting data to the MAR, and MAR takes the data from MBR, and MBR to IR, and taking that data to the or any registers. And these all signals, these all triggers will be given by the control unit. If you have the control unit very fast, it goes too fast processing. And this microprogram is written of nano programs. To control the control unit, we use a microprogram. To control the microprogram control unit, we use a nano program control unit. Hope we got it. And if once the hardwired control unit was set up into a computer, we cannot update it, we cannot change it. We have to break the device and then change the control unit to another. That's what we have to do. It is fixed, and don't call it as software, because there is no meaning of software. And here we have examples of the Cisc or 8086, 8085, Intel also. These all are made up of Cisc processors. These all processors are having architecture of Cisc. And as examples of the RISC, ARM and PIC. Did you know the ARM? Advanced RISC machine. What kind of process are there in the ARM process? We have the Exynos, the Snapdragon, MediaTek, Apple Bionic chip. Many are coming to in the line of RISC because it is faster compared to Cisc. so that all the processor are manufacturing in the form of RISC. The Intel, the Apple once used the Intel process, but now it's using the RISC process. Getting? So you may see how the world is changing from the Cisc to RISC. The RISC is now ruling the process architecture, and which is useful, Cisc or RISC? Depends. Really, it depends. You have the computer. There is large space, and you can also maintain a good cost to invest a good cost onto the computer, and also it have to handle many things, the input devices, the memory, the CPU. There are many things. So we use the Cisc for them, and also when it comes to the RISC, for using a particular thing, particular work, we use the RISC. For example, this is a really great example according to me, that is airbag system in the cars. You know that when something, the vehicle is coming from other side and a dash may occurs and accidents happens, the airbags comes into within, I think, microseconds. Why it's coming that much fast? Because it was maintained only for that work. So for maintaining only for the one work, we can use the RISC. It's really very useful as like a car airbag system which saves our life. For example, if you have used the Cisc processor for the car, think what happens. A person switch on the AC, and also just in a nanoseconds the accident happened. Do the processor do the switching on the AC or produce the airbag? Definitely is the airbag. So that if it is on the AC, there is a failure of construction. There is a failure of construction process. Okay, right? There may be a chance of losing life. So that the RISC is very faster, so that we use those kind of process in those individual things. And this is my brief introduction, a brief difference between the RISC and Cisc. Thanks for watching.